Okay, here we have some extra practice with solving exponential equations. The first three problems that we're going to do would all be calculator aided if you were expected to find a simplified version, because the first three problems will all result in decimals. That being said, if it was a non-calculator one, you could still solve it, but then you would not be expected to come up with the decimal place answer. You could just leave it as a logarithm in the answer. Okay, so I'm going to put one up. I recommend pausing the video, trying it on your own, restarting the video either when you're stuck or have an answer. And then I'll go ahead and proceed through the next three, like I said, all of which, if you were expected to have a decimal, would be calculator aided. Okay, so here we go. First one, we have 3 times 4 raised to the 2x minus 1, all plus 5 equals 42. Okay, go ahead and pause the video, give this one a shot, restart it when you're ready. Okay, so solving for x in this one, we are doing reverse order of operations, so please excuse my dear Aunt Sally, we're starting with that Aunt Sally. Addition, subtraction, what do we need to undo here in this particular case? We have a plus 5, so that means we do need to minus 5 to both sides. Let me grab a different color here so my work can look different than my problem itself. So minus 5 from both sides. We have 3 times 4 raised to the 2x minus 1 equals 42 minus 5 is 37. Okay, next up, we're at the my dear multiplication division. What needs to be undone now? That would be that times 3, so we're going to divide 3 from both sides. And we have 4 raised to the 2x minus 1 equals 37 over 3, or 12.3 repeating if you were to write this as a decimal. Okay. Next up, we are at the excuse, so the exponent piece. So in this particular case, we do want to get rid of that that 4, base 4. So in this case, what does that mean we're doing? We are log base 4ing both sides. So log base 4 and 4 will cancel, and I'm left with 2x minus 1 equals log base 4 of 37 over 3. And last but not least, we're at the please, right? So please excuse my dear Aunt Sally. We did Aunt Sally, my dear, excuse. Now we're at the please. We're taking care of this thing that was in the parentheses up here above your 4. And so in this case, that would mean adding 1 to both sides. And then dividing by 2. And we get x equals whatever 1 plus log base 4 of 37 over 3 all divided by 2 is. And again, if this was a non-calculator, you'd leave it right there. You wouldn't go any further than that. If you wanted to, you could also pick up your calculator, plug it in, and get its decimal. Remember that you always have to have your answers accurate to 3 decimal places, either truncated or rounded. Okay? Next one, we've got 10 raised to the 2x plus 1, all divided by 3 equals 81. Okay, go ahead and pause the video. Restart it either when you're stuck or have an answer. Okay, so here we go. Please excuse my dear Aunt Sally. We've got no addition or subtraction to undo here, but we do have some multiplication, division to undo. We need to undo that divided by 3 by multiplying 3 to both sides. So we have 10 to the 2x plus 1 equals 243. Exponent is up next, so we need to undo that base 10. How do we undo base 10? We log base 10 both sides. Remember, there are 2 ways of writing log base 10. You can write it as log base 10, or you can write it as the common log, which is just log, and that means log base 10 whenever you see a log written without an indicated base. Okay? So 2x plus 1 equals log base 10 of 243. So now we're at the parentheses, so that means subtracting 1 from both sides. We have 2x equals negative 1 plus log base 10 of 243. And then dividing by 2, you get x equals negative 1 plus log base 10 of 243, all divided by 2. Okay, one more in this vein here. We've got 3 times 5 raised to the 1 over x equals 522. Okay, pause the video, give this one a shot, restart it when you're ready. Okay, no addition, subtraction in this one, but we do have a times 3 that we need to get rid of by dividing 3. Okay, so this becomes 5 to the 1 over x equals 522 over 3, which is 174. Okay, and then how do we get rid of that base 5? We get rid of the base 5 by log base 5ing both sides. We have 1 over x equals log base 5 of 174. And then solving for x, we talked about in class a variety of methods that you could use here. Some people prefer to think of it as cross multiplication, so having a 1 underneath this entire thing and cross multiplying. Other people think of it as multiplying both sides by x and then dividing this log over to the other side. Trying to think if there were any other ones we discussed in class. There were some people who considered it as flipping or spinning the fractions on either side, so if you prefer to think of it that way, that works. It seemed like most people preferred kind of the cross multiplication idea, and so I am going to go with that one for the purposes of this video. So we have 1 times 1 is 1, x times log base 5 of 174 is x times log base 5 of 174. And then dividing this log over, we get x equals 1 over log base 5 of 174. Okay. Okay, now we are going to do 2 that also, if you were expected to get a decimal, would be calculator aided. Non-calculator, you'd leave your logarithm in there. But these next 2 are going to use our kind of new function for most of us, or I should say our new number for most of us, which is e. And so we're going to do 2 like this. So first up we have 2/3 times e to the 3x plus 1 plus 8 equals 145. Okay, go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so please excuse my dear Aunt Sally. We do have some addition subtraction in this one. So how do I undo plus 8? I minus 8. Or subtract 8, I should say, from both sides. And so we have 2/3 times e to the 3x plus 1. 145 minus 8 is 137. Then we have a multiply by 2/3, meaning I need to divide 2/3. Remember that dividing by a fraction is the same thing as multiplying by its reciprocal. So technically speaking, what we're doing is multiplying by 3/2 to both sides. And so we'd be left with e to the 3x plus 1 equals 137 times 3, which multiplying 3 to this would be, give me a quick second, 1, 1, 4, 411. Let me quick double check that. We'd have 1 left over 3, 2 left over 7. Yeah, so 411 over 2. Or if you'd rather express that as a decimal, that would be 205.5. If you wanted to write it as a decimal instead of a fraction. Okay, so now we're getting rid of the e. What's the inverse operation of e? That would be log base e, which is what the natural log is. And so we're natural logging both sides. So we're left with 3x plus 1 equals the natural log of 411 over 2. So now we are subtracting 1 from both sides to give me 3x equals negative 1 plus the natural log of 411 over 2. And then what's our last step? The last step is going to be to divide by that 3 to get my final answer of x equals negative 1 plus the natural log of 411 over 2 all over 3. Okay, one more with this base e. So you can practice another one. We have 28 minus e to the x minus 1 equals 12. Okay, go ahead and pause the video, restart this one when you are ready. Okay, so we have, please excuse my dear Aunt Sally, reverse, so addition, subtraction first. In this case, I have a 28 that's being added to that e to the x minus 1, or in this case, negative e to the x minus 1. So if I subtract that 28 over to the other side, we have negative e to the x minus 1 equals 12 minus 28, which is negative 16. Next, we have a times by negative 1, so I'm going to go ahead and divide negative 1 over to the other side. And that gives me e to the x minus 1 equals 16. Excuse me. Inverse operation of e is the natural log. So natural log both sides to give me x minus 1 equals natural log of 16, which means what's my last step? I'm going to add 1 to both sides to give me x equals 1 plus the natural log of 16. Okay. Okay, the last several here are going to be all non-calculator ones. So we're going to do 6 of them. They're going to progress in difficulty as you go. So I'm still going to make the same recommendation, which is take a look at what that problem is, pause the video, restart it when you are ready. But again, these would be non-calculator. Okay, we start with 5 to the x squared minus 1 equals 125. Okay, so I've got nothing added or subtracted to this function. I have nothing multiplied or divided. So we just have to get rid of that base 5. Well, I get rid of base 5 by log base 5ing both sides. And so we have x squared minus 1 equals log base 5 of 125. So remember, to evaluate logs, you're asking yourself what exponent would go above this base. So this would be 5 to what exponent? What would that exponent be to give me 125? And so in this case, that exponent would be 3. Okay, in this case, you now have two options. One, you could add the 1 over and then square root both sides, making sure that when you square root, you should have plus and minus. Or you could subtract the 3 over, which would get this function to equal 0, and then you could factor. You'd get the same two values either way, so it really is purely personal choice. I tend to like the subtracting 3 over myself, because then I would get x squared minus 4 equals 0, which is a difference of 2 squareds. X minus 2, x plus 2, and we'd find our two values of x, which are that x could be negative 2 or 2. And remember, even if you added that 1 over, you'd get x squared equals 4. Actually, let me show that. If we added that 1 over, we'd get x squared equals 4. And then when you square root both sides, you get x equals plus or minus root 4, which is plus or minus 2, which is the same values we get from factoring. Okay? Okay, let's do another here. We have 2 raised to the x squared minus 3x equals 16. Okay, go ahead and pause the video. Give this one a shot. Restart it when you are ready. Okay, so nothing added or subtracted, nothing multiplied or divided, so we can log base 2 both sides. Log base 2 and 2 then would cancel. We'd have x squared minus 3x equals log base 2 of 16. which is asking yourself, what would the exponent need to be above this 2 to give me 16? That exponent would need to be 4. Okay, subtracting the 4 over on this one, we get x squared minus 3x minus 4 equals 0, which does factor to x minus 4, x plus 1, and we get two values, 4 and negative 1. Okay, one more in this vein. We have 2 to the x squared equals 8 to the 2x over 2 to the 9th. Okay, go ahead and pause the video. Give this one a shot. Restart it when you are ready. Okay, this is one that we talked about in class where we run into an interesting situation where I have 3 bases, each with their own exponents, and unfortunately those bases currently don't match. As opposed to over here where my 16 was able to just be evaluated, like I didn't have an exponent attached to it, and so I could log base 2 that side. Unfortunately, if I log base 2 both sides right now, this 8 to the 2x, I would need to somehow figure out how to navigate that exponent. And so we talked in class that my recommendation is on problems like this where you see exponents attached to different bases is take a moment and rewrite this as the same base. So we have 2 to the x squared equals, how could I rewrite 8 so that it's a base 2? Okay, well that would be 2 cubed, which would turn, because it's 2 cubed, would turn this 2x into 6x. And then you have a choice here with what you want to do with this 2 to the 9th. You could evaluate that, figure out what 2 to the 9th is. I could multiply this 2 to the 9th over, and then when you multiply like bases, you add their exponents. Or I could say, well, I'm dividing like bases here, so I can subtract their exponent, 6x minus 9. Now when I log base 2 both sides, both of the base 2's will cancel, and I will be left with x squared equals 6x minus 9. And so then, like what we did here, we're going to get this to equal 0. So we have x squared minus 6x plus 9 equals 0. Factoring, this gives me x minus 3 times x minus 3, which gives me 2 values of x that actually happen to be the same value of 3. Okay, 3 final ones. These ones correspond in your notes to the one that was called the challenge problem. So it gives us some extra practice with that one. We have 3 to the x quantity squared minus 10 times 3 to the x plus 9 equals 0. Okay, go ahead and pause this video and then restart it when you are either stuck or have an answer. Again, if you're looking in your notes, this is most like the one that was called challenge. Okay, so when we did this one in our notes, we talked about the fact that this function here that we've got, as long as it equals 0, it does factor, because technically speaking, what this equation is really no different than if we didn't have 3 to the x, if we called that just x, this would be x squared minus 10 times x, because remember we're calling 3 to the x, plus 9 equaling 0. And so you can factor this x squared minus 10x plus 9 as x minus 9 and x minus 1. Well, since this function factors to these two factors, this function, which is pretty much the exact same function, we just don't have x, we have 3 to the x, it's going to factor the exact same way. We just aren't going to have x here in each of these. We are going to have 3 to the x in each of them. And so instead of x minus 9, this is going to be 3 to the x minus 9. Instead of x minus 1, we have 3 to the x minus 1. And then over here, you would solve this by individually setting each of these equal to 0. So it would be 9 and 1. So we're going to do the same thing over here. We're going to set each of these equal to 0. So equal to 0. Adding that 9 over, then we have 3 to the x equals 9, which means x would have to be 2, since 3 squared is 9. Adding the 1 over, we have 3 to the x equals 1, which means x would have to be 0, since 3 to the 0 would be 1. Okay? Okay, 2 more in that vein, and that will be this video. We have 2 to the 2x equals 4 times 2 to the x plus 5. Go ahead and pause the video. Restart it when you are ready. Okay, subtracting that 4 to the, subtracting that 4 times 2 to the x over to the other side, and subtracting the 5 over, we end up with 2 to the 2x minus 4 times 2 to the x minus 5. Okay, using that same strategy, this function is nothing different than x squared minus 4 times x minus 5. Just instead of x, we have 2 to the x. Okay, this factors to x minus 5, x plus 1. So this guy is going to also factor to x minus 5, x plus 1. We just aren't going to have x, we're going to have 2 to the x. And then solving, we have 2 to the x minus 5 equaling 0, 2 to the x plus 1 equaling 0. Okay, and so then the question is, well, what would make adding this 5 over 2 to the x equal 5, subtracting this 1 over, what would make 2 to the x equal negative 1? Well, if we log based 2 both sides, x would have to be log base 2 of 5. Unfortunately, there's nothing that's going to make 2 to the x equal negative 1, no exponent that you will put above that 2 that's going to turn it into a negative magically. So this one actually only ends up with one answer. Okay, last one. We have 2 to the x equals 16 over 2 to the x plus 6. Okay, go ahead and pause the video. Restart this one when you are ready. Okay, so multiplying our denominator through to get rid of that, or to clear that denominator, we'd have 2 to the 2x equals 16 plus 6 times 2 to the x. So we multiplied this 2 to the x through. And now it looks very much like the last example problem we just did. If I subtract this 6 times 2 to the x over, subtract the 16 over, we'd be equal to 0. So now this function looks like x squared minus 6 times x minus 16 should equal 0. This would factor to x minus 8 times x plus 2. And so over here, this one is also going to factor to x minus 8, x plus 2. It's just not going to be x, it's going to be 2 to the x. So 2 to the x minus 8 times 2 to the x plus 2. Okay, so what would make 2 to the x minus 8 equal 0? What would make 2 to the x plus 2 equal 0? Well, adding the 8 over, 2 to the x would need to equal 8. Subtracting the 2 over, 2 to the x would need to equal negative 2. And where this one there is a value, if x was 3, 2 cubed would be 8. Unfortunately, there is nothing That will make 2 to the x equal -2, and so you only have one answer of x equals 3.